So just a quick reminder, because this will be on your test, what does rational mean? Rational means any number that can be written as a fraction. Okay, so today we're basically going to be talking about fractional exponents. So it's the same stuff we did last class, but now there's going to be fractions in the exponents. Okay, so take a look at this first example, and it kind of gives you, there's like a little key right here. So it says if you ever have a base of an exponent raised to a fraction 1 over n, that is the same thing as the nth root of that number. So this right here is kind of like your little formula if you need it. So on this first example, what's another way of writing b to the 1/2 power as a root or a radical? What would the root be? 2 root, which is a square root of whatever in this case is b. So that would be your answer. B to the 1/2 power is the same thing as the square root of b. So for example, let's say I had 16 to the 1/2 power. What's that the same thing as?
4.
The square root of 16, which is 4. Just another way of writing it. Okay. So if I was going backwards, this example right here below it, this could be written as b to the 1 over 3, 1/3 power. So the root becomes the denominator of the fraction. Now sometimes there's a number on the top of the fraction. So if you take a look here, there's another little formula. So notice the n part is the same thing. The denominator of the fraction becomes the root of b. The m value just stays where it's at, basically. It just stays b's exponent, okay? So for example, if I have b to the 4/3 power, what does the root become? Cube root. So the denominator is the root, and then the 4 just stays where it's at, b to the 4th. So the cube root of b to the 4th. So going backwards, how could I change this back into an exponent with a fraction in it? So b to the, which one goes on top? The 5, and the root becomes the denominator, 5 over 4. So let's do a few examples of that. So example 1, 16 to the 1/2 power, we just did that one, is the square root of 16, which we said is what? 4. Good job. Number 2, how would I rewrite that as a radical, as a root? The 4/3 of x. And the x to the 1st power, so you don't need to write the 1 necessarily. That's not a good root. That looks like a 4 in front. The 4th root is a small 4. 4th root of x. Going on, number 3, I want to write this as a exponent, as a rational exponent. So this becomes 2 to the 4 over 2. Now typically you wouldn't see this here. Like if I write a square root, typically we don't write the 2. So you just need to know that a square root is a 2 root. Now this simplifies, obviously. What is 4 divided by 2? 2. And 2 squared is 4. Okay, number 4. X to the becomes x to the 5 stays where it's at. 10 becomes the denominator. Reduce always, 5 over 10. Divide by 5, divide by 5 is 1 over 2, 1/2. And just now, this would technically be our answer because it says rational exponent, but what is x to the 1/2 the same thing as? The square root of x. Yeah, so the 10th root of x to the 5th is the same thing as the square root of x. And now we're going to apply some numbers to it. So number 5, now we're going to kind of start mixing what we did last class. So we have that pesky negative exponent. So what does the negative exponent do to the 16? Sends it to the bottom. So that becomes 1 over 16 to the 1/4. So remember, a negative exponent doesn't mean a negative number. It just takes that number to the bottom of the fraction. Okay, now we just learned what it means to be raised to the 1/4 power. How could I rewrite this denominator as a root? 4th root of 16. Good. Now you probably know what that is, but if you don't know, it's good to know how to type this into your calculator because we might have bigger roots later on out. But if you want to type in a 4th root, do this with me. Type in a 4. So whatever root you want, type that number. So if you want a 47th root, type in a 47. And then you're going to hit the math button. And then option 5, do you see how it says X root? It'll make it whatever root you just typed in. So that's how you would type in a 4th root, or a 5th root, or a 47th root, or a 2000th root. And the 4th root of 16 is 2. So our whole answer here is just 1/2. Looks crazy. 16 to the negative 1/4 power. That just means 1/2. Now, number 6. I just want to practice typing this into your calculator. So first let's convert it to a radical. So what would the root be? The 5th root of 243 cubed. The 3 stays where it's at. So I just want to practice typing this into the calculator. So the way we do a 5th root, type in 5, math, 5. So the 5th root of 243 to the 3rd power is 27. Now, just so you know how to do this, because it's good to know, most of you probably already know, but we could have typed in the original problem here if we just wanted to simplify. So 243 caret. You guys remember how to type in the pretty fraction? I think I mentioned it last class. How do you type in a nice pretty fraction where it gives you little boxes to type in? Remember from the past? Do what? Not second, it's alpha y equals, yeah. So alpha y equals, and it says n over d, hit enter there, and that gives you the nice pretty fraction where you just type in the boxes. So if I wanted to type in 243 to the 3/5, you can see that's 27. Okay, now we just have to tie this back to a few more of those properties we learned last class. So if I have a base times a base, what did we do to the exponents last class? What? Yeah, we add them. 8 to the, so 8 stays the same. It's like x, if it was x times x, it stays x. And then what is 2/3 plus 4/3? Yeah, so the way we add fractions is we get a common denominator, which they're already common, and then we add the numerator. So 2/3 plus 4/3 is 6/3. So you got to remember some of these, the way we do operations with fractions. 6/3 is 2. 8 squared is 64. Okay, the next one we did last class is we divided bases. And what was our little shortcut? What do we do when we divide b divided by b? We subtracted the exponents. So this becomes b 7/5 minus 4/5 is 3/5. So you subtract the numerators. And that would just be our answer there if we wanted to keep it as an exponent, because 3/5 doesn't reduce at all. If we wanted to, it doesn't say necessarily, but what root would that be? 5th root of b to the 3rd. So that's the same thing. It might just depend on what the directions want you to do, if they want you to write it as a fraction or if they want you to write it as a radical. Okay, number 9. What did we do when I had an exponent raised to another exponent? We multiplied them. So 3 times 1/2. So 3 over 1 times 1 over 2. So we've added and subtracted fractions, but how do you multiply fractions? 3 over 1 times 1 over 2. Straight across, yeah. So numerator times numerator, denominator times denominator. So that would be x to the 3/2. Now the next two are easy because they're even numbers. So what's half of 4? And half of 8. So that would be our answer there. Okay, now the last two, I'm going to do one with you, and then I'm going to have you do 11 on your own. Okay, so the first thing I'm going to do here, I'm going to rewrite this. So 25xy to the 4th, z to the 10th, all over 100x cubed, y squared, z squared, all raised to the, not second power. What's a square root the same thing as? What fraction exponent? What? I heard it. 1/2 power. A square root is a 1/2 power. Oh yeah, so that's okay. So on yours is a square root over a square root, right? That's the same thing as the whole thing square rooted. So those are equivalent expressions. Thanks. So number 10 is the same thing as my number 10. It's just written a little bit differently. But that's good to know. So square root of the top over the square root of the bottom is the same thing as the square of the whole thing, which is the same thing as the whole thing to the 1/2 power. Now, let's do what we did this morning on your warm-up. Let's simplify inside out. So let's start with 25 over a hundo. What's that simplified to? Not 4. 1 over 4. Good. Bigger numbers on bottom. X to the first up top. X cubed down bottom. How many cancel? 1 of each cancel, which leaves how many? X squared on the bottom. Good. So hopefully we're getting better at those. Y to the 4th on top. There's more on top. Y squared on bottom. How many cancel? 2 of each, which leaves y squared left on the top. And then 10 on top, 2 on the bottom, 2 cancel, which leaves z to the 8th on top. All raised to the 1/2 power. So now we just need to raise everything to the 1/2 power. So what is y to the 2nd to the 1/2 power? It's just y. 2 times 1/2, right? We multiply the exponents. What's 8 times 1/2? What's half of 8? Z to the 4th over 4 to the 1/2 power. That's the same thing as the square root of 4. So it's 2. And then x squared 1/2 is x. Same thing we did last class. It's just a 1/2 power. You gotta deal with some fractions. Okay, now give number 11 a shot. Is it the same thing?
Yes.
Yeah, number 11 is the exact same that I have. So give number 11 a shot. Simplify that all the way down inside out, and then we're done. So we can see here everything simplified to the numerator, all raised to the 1/2 power. Trevor, what would I do next? What would the next step be?
I took all the exponents and just divided by 2.
So what about A? Let's do the 4 first. So what's 4 to the 1/2 power? The square root of 4 would be 2. Good. And then exactly what you said. So what's half of 6? 3. And then B squared C to the 5th. And that would be it. Don't forget the 4 in front though, because that also has to be raised to the 1/2 power That's the same thing as the square root. The square root of 4 is 2. All right, that is all.